At 5:29 in the morning, the desert suddenly turned brighter than the sun. A flash tore across the empty plains of New Mexico, lighting the mountains and casting long shadows that vanished almost instantly. The ground shook. A massive fireball climbed into the sky, boiling upward into a mushroom-shaped cloud that no human being had ever seen before. For a few stunned seconds, the scientists watching from miles away said nothing. Then one of them whispered words from an ancient Hindu text, "Now I am become death, the destroyer of worlds." The age of nuclear weapons had just begun. But the story of that explosion didn't start in the desert. It began decades earlier, inside the quiet laboratories of physicists who were chasing something far less terrifying: the secrets of the atom. At the start of the 20th century, the atom was thought to be the smallest building block of matter, tiny, indivisible, harmless. Scientists believed they were simply uncovering nature's puzzle pieces. Then strange discoveries began piling up. In 1896, a French physicist named Henri Becquerel discovered that certain materials emitted mysterious rays, without any visible energy source. Soon after, Marie and Pierre Curie found that elements like radium released enormous energy through a process they called radioactivity. But even then, nobody imagined where this path would lead. Atoms, it turned out, were not solid little spheres. They were more like miniature solar systems, with electrons orbiting a dense nucleus at the center. And inside the nucleus, enormous power was hiding. In 1938, the German chemists made a discovery that would change history forever. Otto Hahn and Fritz Strassmann were experimenting with uranium when they noticed something strange in their results. The uranium atoms didn't just change slightly during the experiment. They split, literally broke apart. When Hahn's colleague Lise Meitner, an Austrian physicist who had fled Nazi Germany, heard about the experiment, she realized what had happened. The uranium nucleus had undergone something never seen before. It had split into two smaller atoms, and when it did, it released an astonishing amount of energy. This process became known as nuclear fission. But the truly terrifying part wasn't just the energy released from a single atom. It was the chain reaction. When one uranium atom splits, it releases neutrons that strike other atoms, causing them to split as well. Those atoms release more neutrons, which split more atoms, and the reaction multiplies in a runaway cascade. In theory, if enough uranium atoms split rapidly enough, the energy release could rival an explosion of unimaginable size. Scientists across the world quickly realized what this meant, and in the late 1930s, the world was sliding toward war. In Germany, Adolf Hitler had already begun expanding his military. Many of the greatest physicists in the world, many of them Jewish, had fled Europe to escape Nazi persecution. Among them was Albert Einstein. In 1939, a group of physicists approached Einstein with a terrifying concern. What if Nazi Germany discovered how to build a nuclear weapon first? Einstein agreed to sign a letter to U.S. President Franklin D. Roosevelt, warning that Germany might be working on an atomic bomb. The letter helped trigger one of the most secretive and ambitious scientific programs in human history, the Manhattan Project. The name sounded harmless, almost bureaucratic, but behind it was an effort involving more than 130,000 people and billions of dollars in today's money. Entire secret cities were built practically overnight. In Oak Ridge, Tennessee, enormous facilities worked day and night to separate uranium isotopes, an incredibly difficult process because the atoms were nearly identical. In Hanford, Washington, massive reactors were constructed to produce plutonium, a brand new element that could also fuel nuclear explosions. And in a remote laboratory in Los Alamos, New Mexico, the brightest scientific minds on Earth gathered to design the bomb itself. Physicists, chemists, engineers, mathematicians. Many of them were barely in their 30s. The project was led by J. Robert Oppenheimer, a brilliant and complex physicist who had an unusual habit of quoting poetry and philosophy while working on weapons capable of destroying cities. At Los Alamos, the scientists faced a challenge unlike anything humanity had attempted before. They had to create a controlled chain reaction and then unleash it all at once. Two different designs began to take shape. One used uranium-235. The idea was relatively simple. Fire one piece of uranium into another using explosives, creating a supercritical mass that would trigger the chain reaction. The other design was far more complicated. Plutonium behaved differently from uranium. It required a perfectly symmetrical explosion, dozens of precisely timed explosives, arranged around a sphere to crush plutonium inward in a process called implosion. If the timing was even slightly off, the bomb would fail. Months turned into years as the scientists struggled with calculations, failed tests, and the constant pressure of wartime urgency. Meanwhile, rumors swirled about German progress. No one knew how close Hitler's scientists might be to building their own bomb. The race felt desperate. By the summer of 1945, the Manhattan Project had produced its first full plutonium device. But no one was entirely sure it would work, which led to one of the most dramatic experiments in history. Deep in the New Mexico desert, the scientists constructed a test site known as Trinity. The device itself was nicknamed the Gadget, a strangely casual name for something that could reshape civilization. The bomb was placed on top of a steel tower. On July 16, 1945, as thunderstorms rolled across the desert, the countdown began. Some scientists worried the explosion might ignite the atmosphere. Others took bets on whether the bomb would even detonate. At 5:29 a.m., the desert erupted in light. The explosion released energy equivalent to about 20,000 tons of TNT. Sand beneath the tower melted into green glass. The shockwave shattered windows miles away. The mushroom cloud climbed nearly 8 miles into the sky. The scientists stared in stunned silence. They had unlocked the power inside the atom. But with that achievement came an immediate and terrible question. What would happen next? Just weeks later, the United States dropped two atomic bombs on Japan. The first, dropped on Hiroshima on August 6, 1945, used uranium. The second, dropped on Nagasaki 3 days later, used plutonium. The destruction was unlike anything the world had ever witnessed. Entire neighborhoods vanished in seconds. Temperatures at the center of the blast reached millions of degrees. Tens of thousands of people died instantly. By the end of 1945, over 200,000 people had died from the blast and radiation. The bombs helped force Japan's surrender, ending World War II. But they also opened a new and frightening chapter in human history. Within just a few years, the Soviet Union built its own atomic bomb. Then came Britain, France, China. The world entered the Cold War, a tense era where nuclear weapons multiplied rapidly. Soon, bombs were no longer measured in thousands of tons of TNT, but millions. Hydrogen bombs were developed, capable of explosions hundreds of times stronger than the ones dropped on Japan. Missiles were designed to deliver them across continents in minutes. At the peak of the Cold War, there were more than 70,000 nuclear weapons on Earth, enough to destroy civilization many times over. And yet, strangely, nuclear weapons have only been used in war those times in 1945. Some historians believe their sheer destructive power created a terrifying balance, what became known as mutually assured destruction. If one nuclear power launched an attack, the other could retaliate with equal devastation, which meant no one could truly win. Today, thousands of nuclear weapons still exist, locked in silos, hidden in submarines, mounted on missiles capable of crossing oceans faster than sound. And it all traces back to that moment when scientists first split the atom, not fully understanding the storm they had unleashed. Because the creation of nuclear weapons was more than just a scientific breakthrough. It was the moment humanity proved it could harness the energy of the universe itself, the same force that powers the stars. And once that knowledge existed, it could never be forgotten. The desert flash in 1945 was not just an explosion. It was a warning, a reminder that intelligence, curiosity, and ambition can lead humanity to extraordinary discoveries, but also to powers so great that the fate of the entire planet can hang in the balance. And ever since that morning in the New Mexico desert, The world has lived in the long shadow of the light. Thanks for watching. If you found this story fascinating, consider subscribing for more deep dives into history and science.